All right, so here's our Precal C exam review. And we're going to start with problem number 1. Here we go. We're going to find all the asymptotes. Keep in mind that tonight is not a night to be asking a bunch of questions. I'm working every problem out for you so you know how to work it. And then you will go home and watch the video and practice again yourself, and everything will be hunky-dory. We don't have time to ask a bunch of questions about each problem. All right, so here we go. We're going to factor the bottom, right? And the bottom factors minus 5 plus 1. Now I need my asymptotes. So I'm going to have vertical asymptotes, and I'm going to have horizontal asymptotes. The problem says find all of them. Okay, so here we go. Vertical asymptotes. Vertical asymptotes come from the denominator.
X plus 5.
X cannot be 5, x cannot be negative 1. So those are the equations of my vertical asymptotes. If you put a 5 in here, what happens? You get a 0. Not allowed. Those are your vertical asymptotes. Your horizontal asymptote is the tricky one. It comes from comparing what's on top with what's on the bottom. And I do not have an x squared on the top. So when I compare 0 over 1, I get 0. So my horizontal asymptote is y equals 0. Number 2, find the remainder. That means I'm going to divide. So I'm paying attention to make sure there's no missing powers. There aren't. It goes x cubed, x squared, x, and plain numbers. So I'm good. I write down those numbers. And then out in the box, I'm going to put a what?
-2.
Negative 2. Draw a line across. Drop this 2 straight down. Negative 2 times 2 is negative 4. Add. 16. Add, negative 50, add. So what's the remainder? Negative 51. This number is the remainder. Find the y-intercept. Now, don't let the equation freak you out. To find a y-intercept, what do you always do? It's always the same. No matter what the equation is, if you're going to find the y-intercept, what are you going to do?
Y equals -2.
No.
Y minus y.
You're going to let x be 0. To find a y-intercept, you let x be 0. So I'm going to rewrite my equation, and I'm putting in 0. Now, take out the x, put in a 0. What is 0.3 to the 0? What is this right here? That's 1. So now I have 28 over 3 plus 4 times 1. What's 4 times 1? 4. So what's my denominator?
12. No, 7.
7. So what's my y-intercept? My y-intercept is 4. If you let x be 0, that becomes 1, so your denominator becomes 7. You have 28 over 7, which is 4. You guys, I will be working on this board only. I don't know if that changes where you want to sit, but since I'm videoing, I have to work on this board only. Okay, so here we go. What is the first step? This is a solve equation.
Factor.
First step is to factor that guy right down there. These, I can't do anything with these. So I'll just factor that end guy. X plus 2, x plus 1.
Multiply the big denominator.
Now I'm going to multiply everything by my common denominator, which is x plus 1, x plus 2. Now notice Mrs. Ford does not shortcut this step because she wants to be sure she gets the right answer. This is, after all, our semester exam. Worth 20% of our grade. It would be super if we did well. So, I'm gonna take my time. Ms. Ford, gives you plenty of time on the exam. You stay late or come early, whatever your exam period fits. So here we go. We're gonna cross out the x plus 1s, and what are we left with in this first term? X plus 2. What am I left with in the second term? 2x plus 1.
Just 7.
And over here, you're right, there's nothing left but 7. So now I'm going to do my distributive, right? So I have x squared plus 2x plus 2x plus 2 equals 7. What kind of an equation is that? Quadratic. So I'm going to get a set equal to 0, collect like terms. So x squared plus 4x minus 5 equals 0. Now what am I going to do with that? I can factor it because it factors, or I could use the quadratic formula if I like that better. This one does factor easily. They don't all factor easily though, so you want to make sure you know your quadratic formula. What does that tell me? What are my answers then? X equals what? -5 or 1. But stop in the name of the law. Go back and make sure that neither one of those causes any problems. They don't. That's a positive 1. Is a positive 1 okay? Yeah, but a negative 1 would not be okay. So you got to check those, remember. Make sure, what?
This is such a long problem.
I know, but we got an answer, so we're good to go. Okay. Number 5, we're going to solve this absolute value equation. This goes way back. What's the first thing we should do with this absolute value equation?
Add 4 over?
Yep, absolutely. We want to add that 4 over, so we got 6 now. Now we're going to split it up into 2 pieces. We're going to split it up into 2 separate equations. One equation just says 3x minus 1 equals 6. The other equation says 3x minus 1 equals -6. The purpose of tonight is to jog your memory, right? You will practice on your own whatever you need to practice. But we're jogging your memory, reminding you of things we've talked about. So 3x equals 7, x equals 7/3, or 3x equals -5 and x equals -5/3. So see how the problem says find the solution set? It says that because there are how many answers? 2. All right. Next.
Mrs. Ford, should
Yep.
the final take us the whole time?
It depends how quickly you work and how much you've prepared.
Okay.
Time was not an issue last year. But that doesn't mean, you never know how much people are gonna prepare and be ready.
And then also, real quick, I heard that one of your academic classes is doing Secret Santa.
Yeah, actually, 2 of them are.
Oh.
Okay, and that was their idea, not mine.
Okay.
Okay, here we go.
Yeah, we're not smart enough.
We're gonna solve this. We need to get x by itself.
Add 4.
So the first thing I'll do is add 4. But groupies, when you add 4,
Both sides.
everything, that's right. So you have 2, 3x, and 15. Do you see how I added 4 all the way across?
Yes.
Now I'm going to do the same thing, only I'm going to divide by 3 all the way across. So 2/3 is less than x is less than or equal to 5, and that's the answer to the question. You're all done. There's nothing else to worry about. All right, what am I ready for? 7. Uh-oh, what kind of an equation is number 7? It's a quadratic. And if it does factor, it doesn't. You would want to factor it if it did, and it would look like you could do it easily. That does not factor. So we're going to use the quadratic formula, which means, by the way, fans, you got to have it memorized. right? This is not gonna be on the test.
You gotta have a word.
X equals negative b. Now let me write it down. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. So for us, that will be 7 plus or minus the square root of 49 minus 4 times a times c all over 2a. So we have 7 plus or minus the square root of 33 over 2. Now, if you can break down your radicand, your discriminant here, if you can break that down, you should. The 33 doesn't break down, does it?
You gotta try it.
So I'm done. Yeah. Gotta have the triangle to cancel. That's exactly right, Jack. So nothing simplifies here. What Jack's talking about, for those of you that might forget, is if you have something like this, this is the answer, okay? This is just extra I'm adding in. If you have something 14 plus or minus 2 root 5 over 6, and you see the triangle of numbers all have a 2 in them, so you can cancel out. But if this number had been a 21, let's say, then you can't cancel, because you can't cancel just part. You have to be able to cancel out of the whole triangle if you're going to do that. Okay, number 8. What is the domain? Okay, we spent a lot of time. Oh, somebody got an idea.
Denominator equals
The denominator cannot equal 0. Remember, when you're talking domain, gang, there's two things you got to be worried about. You got to be worried about your denominator can't equal 0, and you can't have a negative underneath the radical. This problem doesn't even have a radical, so I'm not going to worry about that. I am worried about there's a denominator. So my domain is x cannot be negative 2.
Is that it?
That's it. X can be everything except negative 2. Now, you want to be on the lookout, because this might be a multiple choice question. And it might say that, but it probably won't. It will probably say this instead. Now, nobody is worried about that. You are not worried about that notation, because this simply says you go from negative infinity to negative 2. So think about that on the number line. You go from negative infinity all the way to negative 2. And then you go from negative 2 all the way to positive infinity. Now what does that include? Everything except negative 2. Right? Okay, number 9. All right, f of x is this function, and you're going to find f of x plus 1. Now, don't get freaked out. You all know how to do functions. When you evaluate a function, like if I said find f of 2, you would take out this x, and you would plug in 2, right? That's how you do functions. You take out the x and plug in whatever they want you to plug in. Well, what do they want me to plug in this time? X plus 1. So I'm going to have 3x plus 1 squared. Do not be confused. See this box right here around the x? Take out the x and plug in x plus 1. That's all I'm doing. And then I'm going to come over here and I'm going to do the same thing. Take out the x and plug in x plus 1. Now, guess what you have to do? Well, before we distribute, we need to FOIL. We need to FOIL this first. Always do exponents first. Remember that rule? So that means square this thing. And you don't square that and square that. You FOIL it. So this is going to be x squared plus 2x plus 1. Now I can distribute. So what do I get when I distribute here? 3x squared plus 6x plus 3 minus 2x minus 2 plus 1. Watch it, that's a distributing a negative. So let's collect like terms. We got 3x squared. How many x's? 4. Okay, plus 3 minus 2 would be 1, plus 1 is 2. Now, don't do anything with that. It doesn't say equals 0, it doesn't say anything like that. It says figure out what this equals, and there it is. That's what that equals. That's the answer. All right, here we go, next one. What are we doing here? This means the same as this, if that reminds you, if that helps you at all. Those mean exactly the same thing. That means, this means, take whatever G is, okay? And what's G? This is G, right? Take G and put it into all of the X's in F. So let's see, we got an X here, and we got an X here. So we're gonna take the G function, which is X plus 2, and we're gonna plug it in to the F function. G is X plus 2, that's going into the F function. So we'll have X plus 2 squared minus 3 times X plus 2 plus 1. Isn't that a lot like the problem we just did? It's identical in the math. It looks different, but the way we do it's the same. So what are we going to do first here? FOIL. So that's going to be X plus 2 times X plus 2. So that'll be X squared plus 4X plus 4 minus 3X minus 6. Watch that negative there that needs distributed. What's that equal?
X squared plus X plus 5.
X squared plus X. I like that part. 4 minus 6 would be negative 2 plus 1. Minus 1? There we go. That's the answer. So that you can put check marks next to the problems that you think, oh my gosh, I forgot all about that, I need to study that. So anything that's catching you by surprise, you need to mark so that you know you need to go back and do some more practice on that. Okay, this says sketch. What shape is this? Do not freak out, it's a squared. You're supposed to know what squares look like. They're parabolas. Let's not call them U's, although they look like U's. They're parabolas, okay? Now, do you remember how to find the vertex? You should look at this equation and tell me the vertex. Where's the vertex? 3, 1. The vertex is at 3, 1. Which way does this parabola open?
Down.
Down. Perfect. Done. Easy. That's it. Now the next one is also a parabola. It doesn't say sketch, it says find the vertex. Now, if that equation looked like this, it would be a no-brainer, right? But it doesn't. There are two ways to find the vertex. There's a formula for it. It's probably the easiest. What's the formula for the vertex?
X squared.
X equals
2A. No.
negative b over 2a. That's how you can find your vertex. X equals negative b over 2a. Yep. So for our problem, what would negative b be? 12. And 2a would be 6. So my x coordinate of my vertex is 2. But your vertex is a point. So now you need to find the y coordinate. So you go back to your beginning problem and you plug in 2. So you're going to have 3 times 2 squared minus 12 times 2 plus 4. Now let's not be silly. 3 times 2 squared. What do we do first? Do we multiply or do we do exponents? Exponents. So this is going to become a 4 times 3 is 12. Minus 24 plus 4. What's 12 minus 24 plus 4? Negative 8. So your vertex is at 2 comma negative 8. Now we're going to write the equation that would make all these things happen. Shift the equation 2 units to the left. Stretch it vertically by a factor of 3 and shift it up 1 unit. So I want you to stop and think a minute. They say the equation we're using is y equals x squared. That's your squaring function, one of your BFFs. Everybody knows it. This is what I'm starting with. Now I need to move that thing 2 units to the left. Do you remember how to accomplish that, Karen?
I think so. Wouldn't it be x minus, wait, would it be x minus 2 or x plus 2?
What do you think? It's going to be in the parentheses. It's one of those two.
X plus 2.
It's x plus 2. It's the opposite. Very good, Jack. So the first step would be x plus 2 squared. This is the equation you're starting with. They tell you that in the problem. You are moving it 2 units to the left. And like Jack said, it's the opposite. Now, that takes care of step 1. Now we want to do a vertical stretch. We want to stretch our picture. How do we do that?
Plus 1 outside of parentheses.
Well, the plus 1 outside the parentheses is going to be the last one. That's your shift up 1 unit. But how am I going to accomplish a stretch? I multiply. I multiply. I take this dude right here and I times him by 3. That's going to make him 3 times stretchier. And then as you said, Jack, if I want to move him up 1 unit, I have to put a plus 1 out on the end of the problem. You guys, think back. How many times did we talk about that if it's inside the parentheses, it moves you left and right? If it's outside the parentheses, it moves you up and down. That's the answer to the question. Use interval notation to list the intervals where this guy is increasing.
Don't you do it the opposite?
Just a second, let me get this guy drawn here. Oops, I don't have to have it perfect, but I have to have it kind of close here. Okay. So this is 1, 2, 3, 4, 5. Did I do that right? Yeah. Yeah. Okay, here we go. Now, first of all, interval notation means when you write your stuff, you write it like this, or you use brackets. Remember? What's the difference? The brackets include the number, and the parentheses don't. So if we were talking about from -2 to 5, if we were talking about this set of numbers, we could write it this way. That says everything between -2 and 5, not including. If we colored in the dots, then we would write it -2 to 5 like this. Okay? Now, the question says, do not make this hard. We did not emphasize this, but you can figure this out. Where is it increasing? Well, let's just look at the picture. Start here, trace over it. Where does my pencil go up? Doesn't it go up right here? And isn't it going up right here? Is it going up anywhere else? Right here, right? Okay, now here's the scoop. I want you to look at the x values. At this point right here, I started going up, right? What is my x value at that point? So -3. I'm going to start with -3. Now where do I end going up? It's hard on my picture to tell. I think that's 1, isn't it? Isn't that dot above the 1? So I am going up from -3 all the way to 1. My pencil is going up. Now notice I'm putting x values in here, right? These are x values, always x values. Now where else am I going up? Well, it started here. What's that x value? 3. And where does that end? 4. And put a U in between them because that's the mathematical symbol for OR. That means OR. So we are going up in this interval or in this interval. Now, could we do the same problem for decreasing?
Yeah.
Decreasing would be from -4 to -3, or from 1 to 3, or from 4 to 5. So this is so simple. Increasing means you're going up and you're making intervals from the x values. Wow. We're making good time. Here we go. Okay, here's our picture, or our equation, I mean. I'm going to go ahead, it doesn't say to sketch it, but I'm going to go ahead and do that because I think it might help me. Remember when we did these, we put some dots on the x-axis? Where would the dots go, do you think, on the x-axis? At 2 and 4? Uh-huh, that's exactly what it is. We're at 2 and 4. Guess what those points are called? Those points are called the x-intercepts. There you go. That's the first answer. It says, what are the x-intercepts? The x-intercepts are 2, 0 and 4, 0. Now, how do we find the y-intercept? We've already talked about it. I don't care what the equation looks like. How do you find a y-intercept? Plug in 0 for x. So if I put in 0 for x, what am I going to get?
-2.
-2.
-4 squared is -5/16.
16. So I get -32. So my y-intercept is down here at -32. That's the second question. Find the y-intercept. It's at -32. How do I find the y-intercept?
Plug in the zeros.
For x. That's right. There are like 3 questions on the exam that had to do with that. To find the y-intercept, you simply let x be 0, no matter what the equation is. Now, I want you to sketch this thing for me, okay? Now, in order to sketch it, you got to remember something about this is a cube. If you FOILed all this out, it would be x cubed. What do we know about x cubes? Start down, end up, right? So it's going to start down here, and it's going to come up, and it's going to get to this point. Now, what does it do? That point came from this parentheses. Do you remember? It goes right through it.
It bounces usually.
And at some point, it turns around, so it can come down and get that point, right? Now, what does it do when it hits that point?
Bounces.
It bounces off, and that's your picture. Now, they didn't ask you to sketch it, but they said, at what point is the curve tangent to the x-axis? Tangent means it just touches. It bounces off. Tangent is the real math word for bounce off. So at what point does it do that? 4, 0.
And the have to put in that point.
Yes. All right, that's not too bad. Make sure we're still running over here.
These are so much harder when you use that.
All right, number 16, we're gonna find the inverse. This has some steps to follow. Maybe you remember, it's an easy problem, but you gotta remember the steps. Anybody remember? I've done the first one automatically. Change the f of x to y. Okay, now what do we do? Remember?
Flip it.
Switch the variables. So x equals negative 2y minus 5. And then what do we do?
Put a 0 in.
Nope. We get y by itself. So we simply switch our variables and solve for y. So I'm going to add 5 and divide by negative 2. That is my inverse. So what are my steps again? Switch my variables and get y by itself. Very, very easy. Oh, this should look familiar. Write it in its exponent form. This is the logarithmic form. What would that be in an exponent? So this, yeah, that's right, you're both right. This is what this means. So then when I switch it, it would be, as you said, Maya, e to the x equals 8.
So can we write either or?
Oh, this is the answer. This is the answer, because it says it has to be in exponent form. The only reason I wrote it this way is so you could see the base. This step is just an extra working step. This is the answer, because it says write it in its exponent form. Wow, look at the next one. Write as a single logarithm. You had a test question like this. Write it as a single logarithm. What's the first thing you have to take care of? Pay attention. That's right, I snuck something in there. So we have ln3 plus ln x squared minus ln y. Now you're going to write that as one big giant ln. What are you going to do with the 3 and the x squared? Multiply them. What are you going to do with the y? Divide. So you should have 3x squared over y as your answer.
This one, have you graded our test for today?
Second period is done.
Yeah, I kind of took an L in that yellow backside.
Okay. Well, now we're going to solve this equation.
I don't want to say if it's good on it.
We're going to solve this equation. Now, we've talked about this over and over again. You need to rewrite this equation. When there's only one logarithm, you need to rewrite it. And how would this get rewritten?
4 squared equals 3x.
Exactly. 4 squared equals 3x plus 1. 16 equals 3x plus 1. 3x equals 15. And x equals 5. Perfect. How many questions do we have? So I want to take a break
I
here.
still got like 5 pages.
We have 2 pages left.
We have 2 pages.
Okay.
Double-sided, full. Okay.
All right, let's go for the next one. Now we're actually going to do a sketch. We'll do a couple more, then we'll stop and reset the video. Here we go. We're going to sketch. We kind of just did this in that other problem, but before you can sketch it, you have to do something else. What do you have to do to it? Factor. So when I look at this, pay attention, I can take out an x, and what will I be left with if I take out an x? And what about x squared minus 9? Good. Don't act like you're bored. Be happy you know what to do. It's factored. Now we're going to draw our axis system, and we're going to put our x-intercepts on there. We call them dots. We're going to put some dots on the picture. Where are we going to put the dots? We're gonna put 1 at,
One.
no,
Zero.
no, that's 0. When there's no number, it's just 0.
Negative
Then
three.
we'll put 1 at -3
3.
and at 3.
Why do you put 1 at 0? Is it
Because we have an
there's
x right there.
Right, okay. How come it wouldn't be 1?
You're trying to make it equal 0. If you put -3 in here, you get 0. What makes that 0? 0. If we had a 1, Jack, it would be x minus 1, wouldn't it?
Okay, I thought it's just 1x.
It's x minus 0, so it's a 0. Now, what's the degree? 3. This is another cube. Cubes start down and end up. So I'm going to start down here, and I'm going to grab this point. Now, what do I do here?
Keep going.
Keep going. And then I'm going to grab this one.
Keep going.
Keep going.
Okay,
Grab this one.
go up.
Keep going. There you go. You're done.
So that parent, that was just a paragraph. But
Yep.
It doesn't always.
No.
Okay.
And that one, this one had no bounce off points like our other one did, because in order to have a bounce off point, what do you have to have in your equation? A squared factor. We don't have any squared factors, they're all plain. 3x cubed minus 6x squared minus 3x plus 6. Here we go, we need to list the PRRs, possible rational roots. We always call them PRRs. That stands for possible rational roots. On the exam, it won't say PRRs. It will say possible rational roots. So be sure you know that's what we mean. Okay? What are they?
1, 2, and 3.
Be careful. It's 6, 3, 2, and 1 over 3 and 1. Remember, when we do PRRs, first of all, it's always plus or minus. And second of all, it's factors of last over factors of first.
Oh.
Remember your Beatitudes. The least shall be first. The last over the first. Okay, so what are these? Let's list them. We would have 6, 3, 2, and 1. 6, 3, 2, and 1 all over 1. Then we would have 6 over 3, which we already have. 3 over 3, which we already have. 2 over 3, we don't have yet. And 1 over 3, we don't have yet. So plus or minus all of those numbers.
How did you, wait, okay.
You have to put each of these over 1 and then put each of these over 3.
Oh. That's still the PRRs, right, not the roots?
No, that's the PRRs. Now we have to find the roots. And we just start plugging them in, and what do we hope happens?
It's an easy one.
Well, we hope we get a 0, right? And Mrs. Ford's advice to you over and over again is start with 1. And if 1 doesn't work, either use -1 or 2. Don't be picking 2/3 and something like that. Stay easy. So if I plug in 1, I'll have 3 minus 6 minus 3 plus 6. What does that equal?
0.
0. So now I'm going to divide out 1. So out comes 1. I'm dividing it out using synthetic division, which we did at the beginning on another problem. So down comes the 3. 1 times 3. Add. Did I expect to get a 0 there at the
Yes,
end?
you did.
I surely did. Now, what's left?
3x squared minus 3x minus 6.
Yep,
0.
and I need to factor it. Now, the first thing my beady-little eyes notice is I can take a 3 out. I'm going to do that. Now, does this leftover stuff factor?
Yes.
X minus 2 plus 1?
Yeah.
Now, here comes the tricky part.
Oh, yeah.
It says find the roots. Now, I think all of you would say, okay, x has to equal 2 or -1. But
The one.
don't
The one.
forget the first one you found, because How many answers is this problem supposed to have?
3.
3. Plain numbers don't count. There has to be an x. 3 is not a root. It's just an extra number thrown in there. Your roots are 2, -1, and the one you guessed. Okay? Now, I'm going to stop the video. You can stand up and stretch because it's going to run out of